Good morning. How are you doing? Sorry, I have a dumpster fire I'm putting out for something else separately. That's what I'm looking at over here. I love organizing conferences. It is so much fun and not a lot of paperwork. All right. Last time. How are we all doing today? Is Blackboard down? Yeah. It doesn't know what my user account is. Okay. Neat. I am now an unknown user. Cool. Well, I was going to log in to show you that, we have a homework assignment due Monday. What is going on? Blackboard, why are you looking weird? Unknown user. Okay, well, we'll just pretend. Pretend that it exists. All right, let's move on with class. So yeah, anybody have any questions on the homework assignment? So I guess I can pull it up locally. Documents. That's the individual. Nope. I made it just a Blackboard link. Well, it's gonna look similar. This is not, oh, that's the, yeah, I did just, there it is. Okay, _2. So, due the 15th, right? So that is Monday. This is a group assignment. Everybody good with it? I've had a couple questions come in through Discord on it. There is some issues with GitHub's Markdown syntax. So if you try to do a numbered list where you've got sub items, it's going to show up as like 1, and then I. So like Roman numerals, that's fine for this, honestly. Just make sure that the requirements are ID'd. You can also manually put it into like FR1, FR2, NFR1, NFR2 if you want to do that. But your call. Basically, I want you all to work together as a team on something. So as long as we're good with that, that should be good. One other thing I wanted to address before we get too far into class. So thank you everybody who did the surveys. I looked through them the other day and I wanted to make sure we touched on it. Um, First of all, thank you for all the nice things you said. That was much appreciated and made me feel good. The There was a lot of like common points on the term project with some uncertainty with it, and I know I kind of intentionally have made it open-ended, I guess. And one of the considerations for you all is that at the end of the class, we're looking for a minimum viable product. So it doesn't have to be anything really beyond a functioning demo for it to work, right? We're not doing a full-on project. The important part is the process behind it, the developing requirements, developing use cases, developing test cases, all that fun stuff. So just kind of expectations for that. I am giving you a lot of freedom with how and what to build. So just kind of try to keep those in mind as we go. And with that, make sure you're all still meeting weekly and that you're doing your meeting minutes. I will um, definitely be going in and checking on your minutes as we go. I haven't, as of yet, gone through and itemized everybody's, but I will be checking on that. And if you forgot to check in your meeting minutes, you still have time to get those in. All right. Term project questions at all? I want to make sure there's no uncertainty from your end. But if we're good otherwise, we can crack on with project management. It looks like today I will be pulling it down off of Twitch because I forgot to hit the little record button. Just one of the nice features of doing it on Twitch. When you do Zoom, you forget that, and there's no recording. Here, we can get it still. All right, radio silence. I'm going to assume everybody's good otherwise. So, today we are going to be going over the first of a few sets of slides on project management and planning. So we have talked about requirements, we've talked about use case diagrams. We'll come back to UML after we get through project management, but this is how we now structure our projects. This is going to be how we figure out timings, we figure out resource planning, all of the things you will have to do as a software engineer or a project manager at some point. We're going to go over some different technologies for doing that. We'll look at some different approaches. You basically get to take your pick as to which you prefer. I will show you some of the options. I will tell you this is what I used when I was in industry. This is what people now use in industry. And you can giggle at how antiquated things used to be. And this image here is what Unsplash suggests for project management. Has nothing to do with class other than this is the search result for project management in Unsplash. Which, if you haven't checked that out for Google Slides, it's a nice way to bring in some of those royalty-free, high-quality images that are out there. Right, so project management, project planning. Slide aspect ratio has changed a little bit, so we are back to these other slides here. Again, these are pretty good. I'm going to skip through some of the basic definitions, types of things, the kind of thing that you can basically read on your own. But these are still good. Now, what do we care about for project progress? So again, we're at the point where we should have some requirements. We should have an idea of what our project is going to be. Maybe we've started working on use cases, high-level stuff. But now we need to be able to actually demonstrate that we are moving forward correctly in our process, right? Whether you picked waterfall, whether you picked agile, spiral, whatever your process is, are you hitting these key deadlines, these key milestones? And this type of activity that we're going to be talking about here is what gives you those milestones. This is what gives you that notion of forward progress. And this is going to sound like one of those kind of administrative tasks that sounds awful to talk about and everybody has to do. Yeah, it is. It's not bad, but if you do this correctly, it can make your project go very smoothly. If you skip this step or you kind of slough off this step, you're going to have a lot of problems later on. Just because you start seeing that poor planning leads to poor execution. Um, Basically, be good at organizing is kind of the key takeaway here. So, progress. How do we figure out what our milestones are? How do we figure out what we need to do to move forward? First and foremost, do you actually understand what the customer needs and wants? Do they want a fully featured, perfectly executed application at the end, or are they looking for a prototype? Are they looking for prototypes along the way demonstrating progress? Does their application need a database? Does it need serverless functions? Does it need anything specific? If yes, you can start, you know, laying down points of key progress or sorry, key goals to make. Now, based on what they need, and we're going to hopefully assume that their needs aren't going to change. And if they do, you hopefully have picked Agile as a process if their needs change over time. Can you figure out how to actually build the system that they want? So understand the needs, meaning have good communication skills, have good technical writing skills, be able to lay everything down that has to be done. And then can your team, whoever you're working with, can they actually deliver this product? What are the steps it's going to take to get from project inception to conclusion and maintenance? So can you actually do it? If you can't, who do you bring in to help you? Because obviously we need this customer's business to move forward. If we know the needs, if we know how to build this thing, how long is it reasonably going to take, right? You don't necessarily want to go down to the very specific X days to build this thing. You typically would want to build in a little bit of a buffer for when things go wrong. But reasonably, how long is it going to take you and your team from requirements to maintenance to actually build and deliver this system? And then with that, how much is it going to cost? Right? We have to not only get paid for building the project, we have to pay our engineers, we have to pay quality assurance, we might have to pay licensing fees, we're going to have to pay people's insurance. You know, we have a lot of costs that go into a project. All this needs to be kind of wrapped up into one package here. So just another management consideration. Excuse me. So first thing first, project schedule. Now we have a few different tools which we'll go through in a little bit. There's Gantt charts, there's the burn up and burn down charts, critical path method, multiple ways of figuring out a schedule. How do we actually go ahead and build one of these things? Um, Spoiler alert, you will all be doing this for your projects too. And I will give you the option of what you want to use. But a schedule is effectively going to model this software development cycle that we've picked. Again, whether it's waterfall, notice some of the other ones, prototyping, crystal, whichever one you've picked, we're going to take these particular phases of our project and we're actually going to try to lay down tasks, lay down activities, lay down concrete things that we can accomplish. We're going to set how many days each one of these tasks will take, ideally, and we are going to try and stick to the schedule. And if we go the Gantt chart route, you're going to see lots of like horizontal bars with X days where you're going to see it attached to a particular person. Um, and hopefully things work out right. And if we're at this phase, in theory, we should be able to break things down into tasks, right? So if we, let's say we've picked waterfall because or the V model because we're going more old school. And now we want to break it down into phases. So we have our requirements elicitation, we have our requirements design, we have our verification and validation of our design specs, right? Task one, task two, task three. Um, We get into our development cycle, implement the login form, implement the database interaction, implement the front end, implement the back end. We can actually take those use cases that you're working on and those requirements, and we can say these are tasks to work on. And by having a good understanding of what each use case entails, of who is involved with each use case or requirement, we can very quickly, you know, tag people for these tasks or tag groups for a task if it's more of a nebulous type of thing. So effectively, all this kind of pre-work that you're doing right now with laying out your system ideas, this goes right into your schedule building, which saves you a lot of time. You don't have to start from scratch here. And vice versa, if you start with the schedule, you can then go to requirements and use cases and all that. Again, kind of depends on your preference. With this, so let's say we have tasks, we have phases, we have ideally people and days identified for each task. This also can show you interactions too. So if I have, let's say we're going to talk about implementation details. So implement login form, implement database. We're going to need interaction between these two tasks, right? Because if I have a database, then there's probably a table in there that stores login information. And if I have a login form, I need to be able to call the database. So I can, in theory, develop them in parallel, but by the end, they need to be able to talk to each other. So we might have a dependency between these two tasks, and we can represent that in some of our schedules. But you could extend that to really anything. If we have requirements, then we're going to do use cases. They might be tied together, that kind of thing. Good so far? It's going to be a caffeine-heavy day for me. Okay, so we have now this notion that we need a schedule. Again, schedule, use whatever technology you want, whatever approach you want. As long as you have a schedule, it will help you and your teams. Keep in mind too, so if let's maybe step back a little bit. I am telling you, you need a schedule to keep yourself and your teams on track and on task, right? And if you start missing milestones, missing deadlines, things are bad. Well, keep in mind that a structure on a project can also help with, say, team morale. It can help with focus, and it can help keeping everybody move forward. And this is kind of why this is one of the next things you and your teams are going to be working on is a schedule so that everybody knows what has to be done. Again, we're taking a very light approach to project management and project development for your term projects. And again, giving you carte blanche for what you want to do, just so that it can hopefully be fun for you all. But at this point, you don't necessarily know what needs to be done. Once you add in the schedule, you're going to see all of the key deliverables that you have to do, and then you're going to see the end date of the semester coming up, and this has to be done by then. And then, hopefully that can kind of structure your teams, if not technically, but mentally too. All right, so let's say we're building up our schedule. First thing we need to know is our customers' needs, right? And hopefully we have an idea of this from our requirements, our use cases, our communications with them. But maybe we have other documents. Documents could be emails, they could be chat messages, transcribed voicemails, basically figuring out everything the customer wants and needs. Go back to the requirement solicitation process to figure out how we talk to customers. We also could look at some demonstrations. Maybe we've whiteboarded some functions, some subsystems interactions. Maybe we're kind of sketching out designs. We might be concerned with more non-functional characteristics like reliability or performance. Maybe we're sketching out like a responsive web application where if we go from portrait to landscape, it automatically scales, or if you resize the browser, it scales if we're doing a web app. If we're doing like a physics type of thing, maybe we need highly accurate data or some kind of an embedded system where we need lots of accuracy. Again, this can all feature into your schedule, and figuring out how to implement these inside your project can really inform what your milestones are, what your key activities and goals are. I keep using this term milestone. Anybody know what that is? I've kind of talked about it. I don't think we've ever really formally defined it. Now we see how much of a delay there is with Twitch today. A task completion. A big one. Yes, thank you. There we go. Um, so a milestone is basically it's the real definition is it's like a mile marker, right? So you know you have passed a big step along the path. This could be that our requirements are complete. This could be that our subsystem A is complete and we are ready to move on. Basically, you and your teams have accomplished some big task, like Jacqueline said. It could be a big one, it could be a small one, even. Basically, it is just some, like in the V model, we called them gates. So you pass through all these different gates towards completion. Um, think of it like a nice big green check mark that you can say, we did a good job, we are done with this step, now let's move on to the next thing. We don't have to worry about this anymore unless we have to go back and fix something. So good to have milestones to really demonstrate that progress. Milestones will have deadlines attached to them too. So if you miss milestones, things start to not be good if you keep missing them. All right, so here are some of the definitions that I said I'm going to kind of skip over here. But we have activities, milestones, precursors, durations, due dates. These are all pretty straightforward terms to understand. Milestone is kind of the big one where you have a checkpoint to get by. These terms will be different based on your process and how you schedule things. So in Gantt charts, these are going to make sense because we're going to have activities, which are basically things that we're going to work on for a duration with a due date. When we get into a more agile approach, we're going to have user stories and we're going to have burn up and burn down charts. And these terms aren't necessarily going to make as much sense. In the critical path method, we're going to have, I don't remember what the exact wording is. I think it's still milestone and activities, but kind of the key here is that some of these terms based on your scheduling procedure will be different. The ideas are the same. Do X thing for Y period of time, and it has to be done by this particular date. That's what progress really is. Again, it's kind of a common sense type of thing, at least to me when I look at terms like this, but they're necessary for team-based projects. Even personal projects, if you can do this, helps you along the way. All right, slide time. I'm curious from you all if you have started thinking about some of the key activities that you have to do. Now, I know that you did requirements. I know you're probably getting close to hopefully being done with your use case diagrams. But in terms of what you all have to be doing for your term projects, what are some of the key milestones that you have? Right? What are some of the big overarching tasks that you have to get done? And if you put some thought into this slide, you can basically directly copy and paste it into your schedule homework, which will be appearing after your next one is due, or after Monday's is complete. Basically, I'm just trying to get you to think ahead a little bit here. Again, I've been kind of passively monitoring the Discord chats from for your teams. I know there's it's the checkers team, right? You guys are doing checkers, not chess, I think. Yeah, checkerboard. What are key aspects for you, or key activities? Model the checkerboard, model the pieces, add interaction, handle gameplay, right? There's, who else do we have here? GUI Dancer, getting your stick figure to move, getting your stick figure to move appropriately, encrypt the text file, finish requirements. Yeah, so these are all good activities here, right? These are all things that you can model. I'm just kind of looking over the various rooms in Discord here. I know that some of you are on your own separate servers, which is fine too. Quick question. Yeah, go ahead. Listen to keystrokes. Yep, so that would be the keylogger team. Maybe I should pop this into the actual chat. If our group has kind of jumped ahead, will we still be okay for most of the quests? We just pause and fill out all of the requirements. Could you maybe specify a little bit more what you mean by jumped ahead? Does that mean it broke? Oh yeah, absolutely. Um, that's fine. So if you are, let's say that you are halfway done to implementation, that's fine. Like we're doing a very bastardized form of project management in this class right now, because we have a very short time frame to work with. So yeah, if you're building stuff already, that's great. Just make sure that you have requirements. So just kind of reading your message here, you're probably doing something agile-esque, right? So you're building in tandem with your project management type stuff, which is fine. Yeah. What will be interesting though is if make sure the backend is perfectly fine at the end. Well, backend's gonna have a different definition too, right? So make sure your software artifacts are fine. Yep, yep. And this, you kind of have an interesting use case, and I'm going to assume that most of you, whether you're trying to or not, are going to be following some kind of an agile process. Mainly because I'm doling out these assignments as we go, rather than, you know, allowing you to plan for them, trying to make you a little bit more flexible. But if you are halfway done with your build and I say, okay, now it's time to model out use cases, well, you already have your application half done. Just pick some of the things that you've built. These are my use cases. You already have a prototype, right? So that's kind of a nice thing. And looking at these Slido entries here, these are all good too. Getting sprites to move, bottom one, which I think is the first one that came in. This implies that you have a sprite manager, that you have user interaction. So those would be milestones already handled. Now let's get them to move around the screen. Perfectly fine. Listen to keystrokes encryption. These are, again, good implementation milestones. Test cases complete, requirements, models, checkerboard. These are, well, take the checkerboard one out for now. Requirements and use cases and test cases. These are managing software artifacts. They are a part of the process, so these could be good activities. Finish checkerboard, good implementation milestone. So all of these are good. Basically, as long as you can describe something to be doing, figure out who's working on it, for how long, and when it is due, it is a good activity. And it kind of depends too on how detailed you want to get in your charts as well. Something that is very, very, very fine grained. So maybe let's go back here. Please come back. Okay. Listen to keystrokes. This one, depending on your team, it might be too minor to model out. And I'm not going to say this is bad or good. Again, your mileage may vary for your projects, but if you say that it's going to take me 1 day to figure out keystroke monitoring in Python or whatever language you guys are using, and then it turns out that you actually needed a lot more time for that, that might throw off other schedules. And I'm just kind of cherry picking ideas here. Like if we get stuck on one particular aspect, maybe we should include it in a broader task. So, um, key logging implementation or something of that nature, where we're doing that and we're also transmitting data up to our server. Again, I'm kind of doing a hypothetical here. I'm not saying this is a bad activity or anything like that. Basically, just make sure that your tasks are achievable and manageable is kind of the key takeaway. All right, good points so far. And thanks for the question in chat. That actually is kind of a nice thing to talk about. I've got a fun little quote from Professor DeVries actually on this class in the term project because he does something similar. And I don't have the exact quote, but basically, if you all fail to deliver good projects, but you still have done a good software engineering process, then you actually did a good job, even though everything was broken. because you saw what the real world is going to be like. I get a kick out of that. Nobody wants to hear it, but basically, if you follow your process, then that's almost more important than the project itself, which is kind of odd to think about, but that's what the real world's like. All right, let's get back on topic here. So let's talk about breaking down our work packages into some kind of a structure. So we have a project, right? So you're going to do checkers. One team's going to do key logging and analysis. One team is doing stick figure dancing in a GUI. And there's obviously several others too, right? These are high-level projects. You can break them down into phases. Phase 1, define requirements. Phase 2, define use cases. Phase 3, implementation. You can break those down into further steps, and then you can break them down into very fine-grained activities. And again, this is not the end-all be-all of decomposing a project. Again, you can decompose things however you want. But basically, the idea is to take this high-level generic thing that you have to do and break it down into bite-sized pieces that you can work on. And I know I kind of went back to the key logging and the very specific activity, depending on how you unmodel things. These activities can actually become tasks in your configuration management system. So keep in mind that everything we've been doing kind of links together here. Requirements, use cases, project schedules, back to configuration management. Everything that you're modeling out here, maybe these activities, depending on your level of broadness, you can add these into your configuration management system. You can tie developers and engineers to these tasks in your config management. And then every time somebody checks in code, somebody checks in a requirement, somebody adds a test case, we can tie it to an activity, which can be tied to our schedule. And where all of these moving pieces really come into play nicely is that we can say run reports in our system for task 1.5, listen to keystrokes. Okay, this code was checked in, these requirements were added, these test cases were added, these use cases were added, and then we can very quickly see, this is looking at the project manager perspective, we can see how everything kind of ties together. And if we start seeing milestones getting missed, well, maybe too much time was spent on this task, or we ran into problems with this task. And we can kind of hopefully start to see how this whole picture of software management and software engineering kind of links up together. All right. So in a pure example here for you now. This is a set of milestones for building a house. Now, I've kind of mentioned before that software engineering and like civil engineering or mechanical engineering, they all have very similar kind of notions behind them. Basically, there's a lot of rigor that we're looking for. Nothing stopping you from modeling out a purely physical construction-based activity in similar manners that we would model out a software project. So here is what we need to build a house. All right, we're gonna have to complete a land survey. So you have a parcel of land. Can we actually put a house on this thing? So think of it like an exploratory study for software projects. We need permits. We need to excavate. We need materials. We need to lay the foundation for the house. Kind of skipping through some of these. Exterior painting, interior plumbing, wallboard or your drywall. Add the floors, add the doors, add the fixtures. Basically, here's all of the steps a group or a team would need to build a house. And if you're looking at this kind of thing, I'm not giving you necessarily the specifics of how to lay the foundation. I'm not telling you what type of roof to add on. I'm just saying it has to be done. Does that make sense? So we kind of have generic milestones here. Let's say that we are doing this interior painting phase. Okay, it's going to take my team of painters a solid week to get all the painting done in this entire brand new Oh, I don't know, a two-story house with a finished basement or a one-story house with no basement. Just kind of depends on what you're building, right? I'm not telling them what color to paint. I'm not telling them what type of paint to use. I'm not telling them whether the ceilings should be textured with that kind of, I don't even know what you call it. It catches dust, so the textured ceilings kind of drive me nuts. But again, I'm not giving you details here. I'm just saying do the painting. The requirements would have the more detailed types of things you need to know. But here we just say, okay, painting 2 days, done by March 31st. And that's all we need to know. Popcorn ceilings, thank you. Which hide asbestos. Yeah. Yep. I don't know. Okay, so I'm not going to go on a rant about popcorn ceilings. As somebody who has had to repaint rooms, I really hate popcorn ceilings. Also, as somebody who's had to dust ceilings because the little crevices catch dust. I hate popcorn ceilings. Hmm. Yeah, I don't mind painting, but popcorn ceilings. Ugh. Anyway, I'm sure people love them. Let's take some of these tasks here, or these milestones, and break them down. So, phase one, landscaping the lot. So if you remember, we had that little breakdown, phases, sorry, it was project, then phase, then step, then activity. Phase one, landscaping. Step one, clearing and grubbing. Okay, let's clear the property. Let's get rid of all the grubs. Let's get rid of the trees, get rid of the stumps. Let's aerate everything. So basically, let's get the land into a state that we need to do proper landscaping. Could include having a nice lawn. Maybe we're turning it into a stone, um, like a stone yard, like they have in the more southern regions when there's less grass. This kind of depends. But you see the breakdown of detail here. All right, landscaping, very broad. Step, still broad, clear and grub. Activity, oh, makes sense. Remove trees, remove stumps, aerate, seed, water, shrubs, add shrubbery, whatever you need to do. We're breaking down things into finer and finer grain detail. Start at the high level and then break down. What does this help us with? It gives us manageable chunks to work on. Okay. If I tell a group of contractors or a group of, maybe it's my internal team, go out and landscape, and I don't give them any more detail than that, they're going to do whatever the heck they want. And they'll take whatever they're paid and then they'll move on to the next project, right? Same with software developers, same with software engineers. I'm going to tell you, go build me a user interface. And you're going to say, okay, what kind of user interface? How is it going to work? What are we going to be doing with this? And then either you go and build this thing with no requirements, or you come back and we talk about detailed steps, detailed milestones. Again, we're breaking things down into manageable pieces. How long do we have to work on this piece? When is this piece due by? What do we have to do? Okay, so everything we've been talking so far has been kind of broad, kind of high level. This notion of breaking things down, we're finally getting some more detail. Now we can actually start to model this out. So I'm going to show you the first kind of very high level and mildly helpful for communication between entities here. We're going to look at the activity graph. Now the nodes or basically the little objects are going to be our milestones, and the lines in between them or the edges are going to be what activities we're doing. Excuse me. So here we have a activity graph. And this is still following the house building example. So we're going to start, and then we're going to have our activities. So these circles are our activities, and the edges in between, sorry, the edges in between are the activities. The circles are the milestones. So if we are, say, at milestone 1.4, the next thing we have to do is put down the foundation. And then after that, let's build the wall. And we see here, possible splits, so we could request permits and start surveying at the same time. We can do plumbing and the outside walls at the same time. Basically, we are first and foremost, we're modeling out what has to be done in what order, visually in a kind of a nice, easy to read way, you know, versus something like this, which to some could be less easy to read. But you're also showing interactions and you're showing what can be parallelized. Um, if we have multiple teams, like if we have multiple sub-teams, who's going to work on the UI? Who's going to work on the database? Who's going to work on the back end at the same time? And then we're going to link up when we have all of our, say, RESTful APIs ready or our API hooks or something of that nature. So kind of the key here is be able to lay out your key milestones and key activities in a nice visual manner. This will get you started with scheduling. All right, hopefully it makes sense. Just take that all these milestones and activities you have to do and plop them onto a graph. And this is kind of where IDs are helpful too, because you could point towards 1.1, like right here. I don't have to put all of this text into a figure. It'd get very cluttered very quickly. I mean, even this looks kind of cluttered just because it's compressed. But 1.1, 1.3, 1.4, I can go reference the more detailed, project plan or something like that. So we have an activity graph. We can also add timings here too. So here we now see numbers added in. These are going to be how many, say, person days it would take for an activity to be completed. Maybe surveying is only going to take us 3 days, or I guess 3 hours. This kind of depends on what units of measure you're using for this graph. Usually it's days, but kind of depends on what you want to model out. But we might need 15 days to get the permit. Maybe we're waiting for the red tape to clear at the city hall or something like that. And while we're waiting, we can be surveying. We can, sorry, going the wrong direction, start excavating, start buying materials. So we see 10 days, 10 days, 15 days. Again, you can start to schedule out what has to be done, figure out how long it's going to take, maybe start scheduling teams to be prepared to work starting at such and such a date. Again, taking this back to the software domain, we are going to have requirements engineers. We're going to have test engineers. We'll have, software engineers doing the coding. We'll have project management. We'll have marketing people involved. These are all going to be different groups of people that need to adequately schedule their time. With all of you, you're all students right now. Some of you are probably working. Some of you are probably overwhelmed with school being online. But basically, you're looking to kind of schedule your time between these different tasks, right? From 12 to 2, I'm working. From 2 to 3, I'm in class. From 3 to 4, working on term projects. Basically being able to schedule a project can really, I mean, it's a necessary thing for any good software project. Not sure I'm going with the school being online thing because it's rough for everybody. I'm terrible at scheduling my time for that. But timings, very useful for an activity graph. We can take this and then basically sum up exactly how long everything's going to take. So maybe it's going to take us 3 days to survey the land. Is it actually going to be 3 days to survey, or is it going to be that days 1 and 2 it rained, and day 3 we can finally get onto the property and run our, do our surveying? With these kinds of estimates, it's good to build in a little bit of flexibility in case things go wrong. So activity 1.3, build checkerboard in Unity, for instance. Well, we said it's going to take us 5 days, but it turns out that we are able to find a pre-baked asset and get it done in 1 day. That's great. Now you have 4 extra days to kind of use as a buffer to finalize things. Or if you're not familiar with Unity, it takes you 4 days to model out a rectangle in Unity to put textures onto each particular cell, and then you have a working checkerboard in 3D space, and you still hit your time estimate. Again, flexibility in your schedule can be helpful for unexpected problems. but don't make it like too flexible such that your deadline or your completion date is like way out of the realm of expectation. Right, and I'm not trying to pick on any particular team here, just kind of grabbing examples of things that you might experience. All right, it's good so far. So let's talk about the critical path method, and that's probably all we will get through today. Um, so CPM, this is one way of tracking your progress. Pretty commonly used in construction, so it ties in nicely with what we've been talking about. Sorry, software engineering projects also can use this. I still know many teams in industry that like CPM. Now, this is basically trying to figure out what is the minimum amount of time that you need for project completion. So let's model out all these activities. Let's figure out days worth of effort and whatever the minimum amount of time we need to get everything done, that's our critical path. All right, so let me give you a couple of definitions here because these are going to actually be useful. We're going to try to figure out the actual time something is going to take to be completed. We're going to figure out the available time, which is how much time we have baked into our schedule to do this activity. And then our slack time is going to be the difference between those two. So let's say for building a checkerboard, we budget 5 days. It only takes you 1 day. You have a slack time of 4 days. Or, 2 days to figure out key logging. It took you 3 days. Now you are over your budget. You don't have any slack time, but you've basically blown away that particular deadline. What we're looking for here is to figure out where we have a slack time of 0 at every single node. And when I talk about nodes here, that means we're getting back to a more visual representation. So we're looking for the critical path, or the longest duration without extending the project deadline. So here I've got an example. Each of these bubbles are milestones. Each of the lines are basically the activities in between. Same thing as that graph that I showed you before, except we have months of effort, not days of effort. And the activities are just activity A, activity B, nothing too exciting here. So we have 5 milestones, and we have 2 critical paths. So our critical path is going to be effectively the shortest amount of time, minimum project time here. So, or sorry, we have the least amount of slack time. I'm saying that wrong. So here, if we were to go from activity 10 to 20 to 50, we have 4 months and 3 months. This is 7 months of effort going this way. Here we have 6 months if we go from A to E. Here we have 3, 6, 7 if we go A, D, F. Right? So basically, what we're seeing here is that if we go from on this particular path of milestones, again, here we're kind of modeling a little bit of parallelism here. Maybe this step is not hypercritical, or maybe it is critical, but we can do it in parallel. Basically, we're looking for a minimum project time of 7 months to get everything we need to done. Okay, and this is a little bit, I don't think I'm explaining this well right here, but we're going to need 7 months to get here. We're going to need 7 months to go down this path. We're going to need 6 months to go down this path. All right, so basically what we would see is that we have slack time of 1 month if we went down this way. Because it is a little bit shorter, we would have extra time to play with. It's basically looking at a kind of opposite of how I'm saying where it's the shortest time. Basically, we're saying every path that we can take is going to be 7 months, except for this one, which is 6 months. So we have a slack time of 1 month if we go this way. What this tells us is that we have a critical path of B to C. We also have a critical path of A, D, F. And these critical paths are telling us these steps are going to be what consumes your project's timing. Does that make sense? So basically, if we went from A to E, we would have one extra month to work with in which we could fulfill, one of these other activities possibly. All right, so let me end here, and then we'll talk about Gantt next time. So I do have a Wikipedia link here for you to check out if you want to go deeper into critical path. Basically, what do we need to do? We have to figure out every activity that we need for the project. We have to figure out how much time each activity will take. Sorry, severe dry throat going on. So figure out activities, figure out their timings, figure out if there are any dependencies, and dependencies would be this activity has to happen before this activity, or after this activity, sorry. And then what are the endpoints? So where are we stopping? What are we considering to be a milestone? So again, in this figure here, the milestones are the bubbles, the activities are what's happening in between. All right, we will move on to this one on Monday. And don't forget, Wednesday we'll also do a Zoom session for your term project presentations thus far. All right, all good? Otherwise, I hope you all have a wonderful weekend. Hopefully it's still good. Yeah, and we're not going to spend too much time with critical path. It's more of a technology that you just should be aware of. We're going to go into more detail on Gantt and burn up and burn down charts. So any questions, please feel free to drop by office hours or pop by in the Discord channels. Drop me an email if anything's confusing, but otherwise, have a wonderful weekend. See you Monday. Bye, everybody.